Our first step is going to be to find the volume of the two solids. The first one's a rectangular prism, so the volume is base times height. And the second, bigger cylinder, is also base times height. In an expanded form, the formula is just length times width times height. I can plug in for what I know. I know my length is 6.5, and my width is also 6.5. And finally, I know my height of this prism is 15 centimeters. If I multiply those three numbers together, I find that my total volume of the rectangular prism is 633.75 centimeters cubed. For the cylinder, the base is going to be pi r squared, so the whole formula is pi r squared times height. I can plug in for my r. My r is going to be 15, since my diameter is 30 and my radius is half my diameter. My height is 10.5. When I multiply all three of those numbers out, I get my volume is 7,418.25 centimeters cubed. The next tricky step is how to use proportion to solve this problem. Because I know the water is falling at a constant rate, I can use that proportion to solve for the amount of time it should take to fill up the big cylinder. Because the little one took 8 seconds, the other one should take a time relative to the size of the container. In other words, because that second container is more than 10 times as big, it should take more than 10 times as long to fill up with water. To solve for x, I can cross multiply. So I'll have 633.75 times x equals that other diagonal, which is 8 times 7,418.25. I can multiply out my right side. I can leave my left side as 633.75 times x. I need to solve for x, so I'm going to divide both sides by 633.75 to isolate my variable. I can reduce, that will equal 1x on the left side. And 1x is really just the same as x, so my x value is 93.64 seconds. However, I can convert that number into minutes. So I know 93.64 seconds is the same as 1 minute and 33 seconds approximately. 1 minute and 34 seconds if I round up.